So you should know already that a trapezoid is a quadrilateral. It has one pair of parallel sides, as opposed to, and those are very good, Kenny, those are called the bases. As opposed to parallelograms that have two pairs of parallel sides. So kites, which the reason why we merge it with trapezoids is not because it has anything to do with a trapezoid. A kite is not a type of trapezoid. They really hardly have anything in common, if anything at all. Oh, that's why, because of the, yeah, take those out too, man. Thanks, appreciate it. Happy birthday. But just because they're not parallelograms. Like really what they have in common is the fact that they're both not parallelograms. So now what a kite has is a kite has it has two pairs of congruent sides, but unlike unlike a parallelogram, the pairs of congruent sides are consecutive. They're not opposite, they're consecutive. Now there are some similarities with certain parallelograms, like for instance the diagonals. The diagonals of a kite are perpendicular. Even though a kite is not a parallelogram, but what parallelogram did we study that has perpendicular diagonals? Yeah, I don't know who said it first though. I don't know who said it first.
I said rhombus.
Yeah. Well, it's a rhombus and a square. Yeah. Rhombus and square. Among my many criticisms, I guess I don't have enough handwriting. We would learn better if it was in my own personal handwriting. But here's another fact about kites: the non-vertex angles are congruent. So think of it this way: if you're not, because there's two sets of angles. There's the vertex angles and the non-vertex angles. Those are labeled for you. I told you that a kite has two pairs of congruent sides. Two of the sides are the same. Two of the other sides are the same. Where the sides that are not the same meet. So like here, this has two slashes, this has one slash. Where those meet, those are not congruent, those are the non-vertex angles. Who said that? Consecutive means next to each other. You might be thinking of supplementary. So those two non-vertex angles, which are again where the non-congruent sides meet and the one across from it, those are going to be congruent. The vertex angles are not congruent. The vertex angles are where the sides that are the same meet. But let's go right here. The vertex angles, the vertex angles of a kite, and I gave you plenty of space, so feel free to do like the cavemen did, and you can always write this down. If it's confusing for you to read like this, you can always write it down in your handwriting. But those vertex angles are bisected by a diagonal. And I'm having some, see if I can do it with my mouse, because I can't do it with my finger. See if I can get one of these out of here. There it is, better. Okay. So see the diagonal that I left there is the one that connects the vertex angles. That angle is bisecting the vertex angle. So if I were to tell you that like this was 30 degrees, this would be 30 degrees. If I were to say like this is 45 degrees, that is not true about the non-vertex angles. What is true about the non-vertex angles is that they're congruent. So if I tell you that this is 100 degrees, how much is this? Yeah, so those are the same. The fact about the vertex angles is that they're bisected. What other parallelogram has angles that are bisected by a diagonal? A rhombus, yeah. I know you did that. Penny, it's because I like her better. The rhombus. Then obviously the square, because the square is a type of rhombus. One other fact, when I draw both diagonals at the same time, the diagonal that connects the vertex angles, which here looks like the longer one, that cuts the other diagonal in half. So like in this diagram, I've already used 1 slash and 2 slashes. I would then use 3 slashes to say that those two are the same, but not vice versa. They don't bisect each other like parallelograms do, but one diagonal does bisect the other one. Just like when we learned about parallelograms, I listed all those facts for you in one convenient place, so you can learn, what are some properties about the sides of a kite, the angles of a kite, the diagonals of a kite. You can ignore what's in blue in the parentheses because that's if we were doing coordinate geometry, but we won't be. If you were here earlier today before class, I also told you this will not show up on the test this Thursday, but it will show up on the assignment, on that written assignment. Kite and trapezoid, yeah. All right, let's do some examples. What is this? It is a trapezoid. If, this is what we introduced on Friday, if A and B are midpoints, what do you call a segment AB? A mid-segment. Trapezoids have mid-segments, can have mid-segments, just like triangles do. The difference is how it's calculated. On a triangle, the mid-segment is just half of the third side. On a trapezoid, it's half of the sum of the bases. You gotta be good with writing equations, but once you get used to this, Bazzi, it's not too bad. Half the sum of the bases. Okay, so what's one base here? Okay, what's the other base? No, that's not a base. The VT, and coincidentally, that's what we're looking for. So I could say VT plus the 26, that's the sum of the bases. If I wanted to cut that in half, the easy way to do that is to put divided by 2. And that should equal the mid-segment, which in many cases that's what we're looking for, but here we're not looking for it, we know it. What is the mid-segment here? And it's very similar to mid. It's the exact same thing as a midpoint formula. You wouldn't have done that with me. That might have been at the beginning of the year, because I did that at my last school. We were doing. Did you guys do midpoint formula with your first teacher? Where you just like add the x's, divide by 2, add the y's, divide by 2. The same thing. Just finding the average. You have to see it. That's what we're doing. Like if I were to tell you, what is the midpoint of 5, 9, and negative 12, negative 17? You would just add the 2 x's and divide by 2, and add the 2 y's and divide by 2. Well, structurally, it's the same thing. Cool. So times 2 to get rid of the 2 on the bottom. So Bazit, VT plus 26 is equal to 30 minus 26 minus 26. VT is equal to 4. What I see a lot of, and it's like I have an ethical issue as to whether to teach this or not, because it doesn't mean you know it, but nowadays it's all about what you can show on a test, right? So what I see a lot of people doing also is just saying, all right, well, how far away are those from each other? Like distance-wise, if you were to subtract them. 11, right? 26 minus 15 is 11. If I go 11 the other way, what's 15 minus 11? Yeah, 4. But that's not here. Okay, that's not the formula. And the second I put a fraction in there, you're done. Good luck with that. So, no, because then you might even have to round it. Once you round again, you're done. So right here, because of the markings, they're showing us that A and B are both midpoints. Therefore, AB is a mid-segment. This is a more traditional type problem where now we're actually looking for the mid-segment. So I can just say this AB is equal to the sum of the bases, as hard as that is. 54 and 86, and then you got to divide by 2. You're taking the average of the bases. 54 and 86 is 140. 140 divided by 2. So the length of AB is 7. Just for you, Kenny. If you need help, Bazid is offering tutoring after school. He's right behind you. You okay? Okay, these are kites. Find the following. So remember, kites have consecutive sides that are congruent. So like if I were to label all of these, this is the same as that, these two are the same. I don't know how your copy came out, but if you can't read any of these, just write it in. So they want to know first SV. SV is one of the sides of the kite, and that's 6x minus 22. What would that be the same as? They want to know what is SV, which is here. So I need, and it has an x in it, so I need to write an equation. That is the same as ST, which that says 2x plus 2. So solve for x minus 2x minus 2x plus 22 plus 22. 4x is equal to 24, so x is 4. But then be careful with these, because that's x, but they wanted SV. So I have to plug that back. Now, if you want to be clever, maybe like, I don't know, 6 times 6 is too much for you or something, and since both of these are congruent, you can even plug this 6 into the 2x plus 2. It's the same. Give you the same thing, but I'll live dangerously and say SV. SV is 6 times 6 minus 22, which is 36 minus 22, which is 14. Let's look at the next one, UVZ. So UVZ. If the diagonals were not being shown, what type of angle would angle V be? Non-vertex. Why non-vertex? Because that's what the two sides that are not the same mean. What do we know about non-vertex angles? Well, we don't know anything about them with reference to the diagonal. All we know is that it's the same as the one across from it, but they're not giving me any information about t. But if I wanted to be clever, because that's part of the reason, a lot of kids think that geometry is overall easier than algebra 1. But one of the things, if you disagree with that statement, part of it is that I think geometry has more to memorize. And yeah, in algebra 1, you're still accountable for what you did before, but since it's kind of like the stuff that you've done before is used more frequently, it's a little harder to forget. So look, here, in order to find this, I wouldn't even use anything I've learned about kites. I'll use what I know about triangles. That makes a triangle, right? One of the angles in that triangle says 9x. Another one there, it's hard to see, but I can't even see it. Did I say 6x plus 45? Yeah. You can't see that on your side? No. All right, let's just assume it says 6x plus 45. So if I add plus 6x plus 45, if it doesn't work out well, we'll change it to a minus. You think it's a minus? See, 15 is going to be, no, I think it's going to be a plus. I think it's going to be a plus. So let's combine like terms, like the cool kids do. 9x and 6x's. 9x and 6x's. 15x, this is a plus 135. Is equal to 180. Minus 135 minus 135. It is going to be 45. Now, and even then, look, another one you could have even used is on a right triangle. That's what it is. These are complementary. So I could have even just done 9x plus 6x plus 45 is equal to 90. That would have worked also. Either way, you end up with 15x is equal to 45, divide by 15, so x is 3. If they want to know what that UVZ is, then that was a 6x plus 45. So measure of angle UVZ is equal to 6 times 3 plus 45, which is 18 plus 45, which is 60.
So how do you know?
By knowing your properties. Why did I make this equation equal to 180? How many angles did I use? No, how many angles did I use in the formula that I wrote, in the equation that I wrote? I used all three. What do all three angles in a triangle always equal to? 180. But there is one more, and it's actually a corollary. It's not even a theorem. It's a corollary that says that like it just goes with triangle interior angle sum. Because if I know that one of these are right, I can just get the other two and make them equal to 90. Would have worked the same. Because if all the degrees add up to 180, and I take away 90 of them, how many are left? Okay, the last one says VT. VT is the length of an entire diagonal. That is the diagonal that's connecting the non-vertex angles. We learned that one gets cut in half by the other diagonal. I can make those two expressions equal to each other. 8x plus 2 is equal to 2x plus 26. Minus 2x minus 2x minus 2 minus 2. So 6x is equal to 24. Divided by 6, x is equal to 4. Huh? Now, if I want to find that entire diagonal, I can plug the 4 into both of those and add them. Or, since they're both the same, I could just find one of them and multiply by 2. Either one would work. All right, well, whatever Alfred wants. Way, delete. So he wanted to multiply by 2, so that's fine. We'll just then say that VT is equal to 2 of them times, let's just use the, what do you want, I'll let you pick off. Do you want to use the 8x plus 2, or do you want to use the 2x plus 26? All right, 8x plus 2. So 8 times 4 plus 2. 8 times 4 is 32, plus 2 is 34. 34 times 2 is 68. Yeah, 34 times 2. 3 times 2 is 6, 4 times 2 is 8. Given this isosceles, okay, what did we learn about isosceles trapezoids? Trapezoid is isosceles, what does that mean? Which ones? Not the bases. The bases can never be congruent. The legs are congruent, yeah. So, I don't know if we're going to need that or not, but we'll see. WZ. So WZ is a base. Here you go. For those of you planning on just adding and subtracting to find a mid-segment. Here they're calling it a median. I don't know why they call it a median, but just assume it's the same thing. We have to use a formula. So one base, that WZ that we're looking for, is 12x plus 22, plus the other base, which is 8x minus 2, over 2 is equal to, what's that mid-segment? How long is it? Add up the two bases, so I added up this base with this base, divided by 2 gives you the mid-segment, which is 120. So 20x plus 20 over 2 is equal to 120. Normally I would multiply by 2 to cancel out the 2 on the bottom, but actually both of those on top are divisible by 2, so I could just say 10x plus 10 is equal to 120. I just divide both of them by 2. Minus 10, minus 10, so 10x is equal to 110. Divide by 10, x is equal to 11. We wanted to know WZ, so I plugged that back into 12x plus 22. WZ is equal to 12 times 11 plus 22. that gives you 120, 132, the 154. You want a candy?
Doesn't matter what number where you plug it in.
Yeah, because the question was asking you for WZ. They wanted to know, I know it's hard to read, but they wanted WZ. So I plugged it into their WZ 12x plus 22. Okay, on an isosceles trapezoid, base angles are congruent. As long as the angles are part of the same base, they're congruent. So if they were to give me angle W and angle Z, those two would be the same. They don't give me those. They do give me these, those are the same. And they want to know XWZ. Ooh, okay, that's going to be an interesting one. And they want to know that angle there. Any ideas? They want to know this angle here, which I'm not getting any information about. Let's say I were to able to find angle X, which is the consecutive one. It's the one next to it. What's true about the consecutive angles on any trapezoid? Jair, say it better. They're not congruent. Supplementary. They are supplementary. So, but we need to find angle X first. So we'll start off by saying 3x plus 7 is equal to 5x minus 21 minus 3x minus 3x plus 21 plus 21. So 28 is equal to 2x. So we get 14 is equal to x. So now the measure of angle X is going to be 3 times 14 plus 7. That's 42 plus 7, which is 49. Once I know that that one's 49, if the consecutive are supposed to be supplementary, what would the measure of XWZ be? Measure of angle XWZ would be, if it's supposed to be supplementary with the 49, how would you get it? 180 minus. You said it was what, 131? No. No, 131. That's on any trapezoid. On any trapezoid, consecutive angles are supplementary. Because they're same side interior. And then Kenny, our favorite, another reason why you can't just assume that you can count to find a mid-segment. I had mentioned fractions, but I should have also mentioned this. How about if you have an unknown? You need to use the formula. What are the lengths of the two bases? Here they want to know Mn. Mn is the mid-segment, but we need to know what X is. Okay, let's add the bases, but the bases are X plus 8 plus X plus 2. Then you're supposed to divide by 2, and that gives you the mid-segment, which is 2x plus 3. There's 2 x's and plus 10 over 2 is equal to 2x plus 3. Normally I would multiply by 2 bazit to get rid of it. Bazit, did I tell you that I met one of your wrestling coaches on Friday? Said I should just go talk to him if ever you get sleepy. It'll help you stay awake. Huh? Minus x minus x. So 2 is equal to x. Now that I know that, Mn is 2x plus 3, so it's 2 times 2 plus 3, which is 7. Any questions? Leilani? The measures of the bases of a trapezoid are, this one let's just do it verbally because we've done already enough of these. If the measure of the bases of a trapezoid are 8 and 26, what's the measure of the midsegment? Just add them and divide by 2. Who said 17 first? Yeah, just add them and divide by 2. 26 plus 8 divided by 2, 17. Alright, let's do one of these. Ooh, fun. This is called a composite figure. Because this is a kite that shares a side with a trapezoid. So let's find this measure of angle y. Okay. Well, y is one of the base angles on the bottom of the trapezoid. And now this is isosceles, so I know, I'm just trying to think out loud. I know down here that this would also be y because the trapezoid is isosceles because of those marks. On a kite, the non-vertex angles are congruent, so this is 137, and it looks like that's what's going to be the one that helps us here. Because even though this might be a little confusing, because of this arc, I mean, what I'm interpreting is that this angle would also be 137. And if this angle is 137, what's true about the consecutive angles of any trapezoid? Supplementary, yeah. So it would just be y is equal to 180 minus 137, which is 43. This is a trapezoid. The measure of angle C is 3 times the measure of angle B. So what is the measure of angle B? This is an isosceles trapezoid. Huh? Where are the numbers, right? There's no numbers. Yeah, we have to provide the numbers. Shaylee can provide them too. She knows all the numbers. Because this is isosceles, what is angle C the same as? Angle A, yeah. If you go along the same base, those angles are the same. So A and C are the same, right? So, if they're telling me that the measure of angle C is equal to 3 times the measure of angle B, and they want to know what B is, well, the equation I could come up with is, since those two are the same, and I know consecutive angles are supposed to equal 180, I can substitute, and instead of angle A, I know A is also 3 times the measure of angle B, so I would say 3 times the measure of angle B, because that's the same thing as A. Because A is, that's a, what is that, transitive property? If A, then B, and B, then C. So if A and C are the same, and C is 3 times the measure of angle B, so is A. So 3 times the measure of angle B plus the actual angle B would be equal to, if they're supplementary, they'd be equal to 180. How many angle B's is that in total? If there's 3 angle B's here and 1 angle B there, how many angle B's are there? So 4 times the measure of angle B is equal to 180 divided by 4. That should be 45. And that's what they wanted to know. So 45 degrees. Angle B is 45 degrees. If they wanted to know what angle C was, then what would angle C be? No. Angle C is 3 times that. 135. Find the perimeter of the kite. That's not a fair one. We can't do this one. Well, I mean, how many of you guys have seen Pythagorean theorem already? Yeah, we're gonna have a lesson on that coming up, but you need that for this. Some of you may have seen it before, but I'll just skip this one. That's not gonna be. Well, none of this is gonna be on the test. It shouldn't be on the homework either. But yeah, that's what you have to do. You have to use Pythagorean theorem to find this. Once you find that side, it's the same as that side. You use Pythagorean theorem here to find this side, and then it's the same, and then you would find this further. But I'll just skip that one. Here's an isosceles trapezoid. If you learned from the last one, on an isosceles trapezoid, what are opposite angles? They're not congruent. They're supplementary. 12x plus 25x plus 32 is equal to 180. 37x plus 32 is equal to 180. Minus 32 minus 32. 37x is equal to 148 divided by 37. Is that 4? 148 divided by 37. Haley, did you get 4? Oh, I forgot to, Shaylee, from now on, I moved your seat. And if you want me to move you further back, let me know and you can just speak. But make you remember that that's your seat from now on. Just stay there for today because we're almost done. But find the value of x, so we're done. All right, I'll let you decide. Right now it's 8 o'clock. I can either finish up the lesson or we can do a Kahoot on similarity. Does anybody want to finish this? All right, so we'll do this then. If you want to finish this on your own, you can. And if you have any questions, see me before class independently. For the Kahoot, you can use your phone if you got it. I don't have enough time to pass out the laptops. We need dramatic music. Oh, the music's not gonna come on because I have it muted. Shaylee, you're gonna miss the Kahoot. You can get on the school's Wi-Fi. The school's Wi-Fi. He can't hear you because he's wearing his earbuds. It's just that he doesn't hear that well out of his left ear. Bazit! Kahoot! Kahoot, Bazit! Put your, if you put your real name and you win, I'll give you a candy. If it's a fake name, I'm not gonna give you a candy if you win. And let's do this quick. There's 14 questions on this one. I'll give you like another 30 seconds and now I'm starting. The game pin will still be displayed on the bottom even if you jump in late. Did you spell your name wrong? Yeah. Oh. You're awake. Bazid is in the house. All right. I'm starting. If you want to join in, this pin is still going to be showing on the bottom. The game pin is still down here if you want to join. Oof, only one person got it right. Let's see. All right, so the angles appear to be complying. Because remember, on similar polygons, angles are, or at least corresponding angles are, congruent. No, they're congruent. So one arc N corresponds with W. L corresponds with V. They're congruent. There's both K and U are both 90. J and T both have 2 arcs. But yeah, and I know there wasn't that much time, but you have to check the sides. And what I would cue in on is these. So these 2 sides correspond, right? What's 6 divided by 6? 1. Because corresponding sides are supposed to be proportional. So in order for these polygons to be similar, every single other side would have to also divide and give you 1. What's 12 divided by 6? 2. So they're not proportional. They have to abide by the same scale factor. It's not. So one person got it right. Me is winning. So are these polygons similar? Now these are triangles. Okay, so these should have been similar. Remember, with triangles, there's shortcuts. You don't need to know anything about the sides as long as 2 sets of angle, as long as 2 sets of corresponding angles are congruent, you don't need to know anything about the sides. Now, to be honest, I wouldn't trust where this is coming from. So I guess I would still check the sides, but even if you wanted to check the sides, look, in between the 1 arc and the 3 arcs is 16. Over here between the 1 arc and the 3 arcs is 20. So if you were to make a scale from that, 16 over 20, that gives you 4 over 5. So all of these should be 4 over 5. In between 1 and 2 is 8. In between 1 and 2 over here is 10. What is 8 over 10? 8 over 10 is also 4 over 5. And then the last one would be 12 over 15. 12 over 15, if you divide each one by 3, also gives you 4 over 5. They all abide by the same scale. But in reality, like if this were coming just not from a Kahoot in the middle of the internet, if this were like an actual official like standardized test, we wouldn't even need to get that far because on triangles we have shortcuts. These would be similar by angle, similarity. What is the scale factor of the polygon? So that means that these already have to be similar. Just what's the scale factor? Oh man, did I just do that for you? Yep. You're welcome. But Z, you're missing out. You're not answering it. So you gave up already? If at first you do not succeed, give up. Somebody let the whole time pass? It's like I just did that for you. Or if that colon, those are, you can, sometimes you might see ratios explained that way. It's the same thing as a fraction bar. So that's 4 over 5. I just showed you that. Find the value of x and y. So these are similar. We'll assume that they're similar. Find x and find y. Try to see if you can find the scale factor there. Okay, the green one. What was the green one? What was the scale factor here? Scale factor is a ratio, or we compare. This is a little trapezoid and a bigger one, right? The only one that we know corresponding measurements is here, 6 and 9. Because there's a 5 on top, but I don't know anything about the bottom. The 7.5 on the right doesn't help me, but that's 6/9. That reduces to 2/3. So now to find y, it would be 2/3 times 5, which that gave you approximately 3.3. I'm not a big fan of round. Oh, sorry, yeah. 3.3. Not a big fan of rounding, but you had to. And then 2/3 times 7.5. That's what gave you 5. And that's what the green one said. Did they have that backwards?
Yeah.
Oh, look at that. That's why you got it confused. Yeah, it should be backwards. I didn't write this. I just found it and I tried to modify it a little bit, but I didn't catch that. It should be backwards. X is 5 and y is 3.3. Sean. The scale factor of pi is 2 is that's the same thing as saying 8/5. So what would be the scale factor if you were to flip it around backwards? Okay, thank you for that. Okay, good. Are these figures similar, and if yes, why? Bell rings at what, 16? 8/16. Side, side, side. If you divide the corresponding sides, they all have the same scale for that one. Are these figures similar, and if yes, why? Ooh, should be an easy one. Anytime you see parallel lines, they're trying to get at something. We have a practice test tomorrow. This is going to be prominently featured. Angle, angle. If you see parallel lines, they're trying to tell you something about the angles. Why are the angles in the middle here? Why are those congruent? They're vertical. And then because of these parallel lines, we actually have a pair of alternate interior. C is the same as M by alternate interior. P is the same as A. Are these figures similar? If yes, why? When you are referring to an angle that's in between two sides, what do you call that angle? What word would you describe an angle that's in between two sides? Who said it? No, with a girl's voice. So the included angle here was a 70, and then the other the sides have to be proportional. 20 divided by 16 is the same as 15 divided by 12. Ooh, Mickey in the lead. Couple minutes left. That one's no, because the only thing it could be is angle, angle. But when you find that missing angle, they don't match up. They both have a 35, but the one that's missing doesn't match up. But if you did the math, up here should be 120, and then the other one down here should be what, 35 also, not 25. Okay, Mickey's still in the lead. This might be the last one. Might have two more. Either this one or maybe one more. Let's assume these are similar. Find the scale factor. Helps to have a calculator. No, I'm not gonna skip it. Yeah, this will be the last one. Scale factor is 7 over 24. Just do 9 times 7 over 24. 27 times 7 over 24 to find the x. I would need a calculator too. It looks is yellow. Okay, so let's see who's in the lead after this one. Mickey, there you go. Another starburst for Mickey. All right, tomorrow we got a practice test. I'll have the printouts of the assignment for you tomorrow, but if you want to get it early, get it online.